Hello, good afternoon, everyone. Today we are to discuss with the topic having heterofuse benzofuse heterocyclic moiety, that is benzofuran. Today we are to discuss with the heterocyclic moiety having benzofuse with the heterocyclic moiety, six-member heterocyclic moiety, that is pyridine, benzopyridine containing components. Here, today we are to discuss the ring having pyridine along with benzene, that is benzopyridine, that is quinoline. Benzo fused with the pyridine at 2-3 positions on pyridine ring. Another pyridine with the benzopyridine ring is the isoquinoline. Here we have to study or discuss with quinoline instead of isoquinoline. In next sections we have to discuss with the isoquinoline. Here we have to discuss the property of isoquinolines, some chemical preparations of quinolines, chemical reaction of quinolines, and some important medicinal drugs having quinoline is a moiety present in the structure and it exert the particular actions. Now we have to move with the quinoline as a aromatic compound. First property of quinoline is aromatic in nature. Quinoline is aromatic in nature. The structure of quinoline is benzene fused with the pyridine rings. Here pyridine is nitrogen containing heterocyclic moiety. They fuse with the benzene rings at these junctions. A side, B side. This B side of pyridine, they are bind or fuse to make quinoline as a fused structure. Here benzo is a prefix for benzenes. This is a side where the benzo is substituted. That is B side of pyridine. The name of quinoline is benzopyridine. It's a IPC name for quinoline, or in the common name quinoline you have to return in the form of 1-azanaphthalene. This whole ring is naphthalene ring. In naphthalene ring, one position the aza is present. That's why the alternate name for quinoline is 1-azanaphthalene ring. The numbering starting in quinoline ring system from nitrogen atom 1, 2, 3, 4, 5, 6, 7, 8. Total 8 positions are present in quinoline. All the atoms present in quinolines are sp2 hybridides and planar in natures. Here in the quinoline, total 10 delocalized electron present in the structure. So due to the presence of delocalized electrons, 10, this delocalized electron came from the carbon of 9 electrons and 1 from nitrogen atom. Total 10 delocalized electrons, which follows the Huckel's rule. As per the Huckel's rule, 4n plus 2, we are putting n is equal to 2, that is 4 into 2 plus 2. If 10 pi electrons or 10 delocalized electrons present in the systems along with alternate single double bonds and cyclic system, those compounds or those structures are aromatic in character. So the quinolines are aromatic in nature. Another property, quinolines are weaker base. And third possibility, there are partially bind by sharing of this unshared electron present on nitrogen with hydrogen and to make the partial hydrogen bonding with this quinoline ring. Why? Due to the presence of lone pair of electron present on nitrogen atoms. This showing due to the presence of this unshared electron present on nitrogen, they bond between other hydrogen of other rings and to make the hydrogen bonding property with quinolines. These are the properties of quinolines. Now we have to move with the some important synthesis. How will you prepare the quinoline structures? The preparation of quinolines, or another, alternatively you have to call as synthesis of quinoline. The first important synthesis of quinoline, that is Skraup quinoline synthesis. In this Skraup synthesis, requirement for the formation of this quinoline, the aniline is the requirement. Aniline react with the glycerol in presence of acid as a catalyst with mild oxidizing agents. Here the oxidizing agent is nitrobenzene is used as an oxidizing agent. This aniline and glycerols undergo cyclization and to make the quinoline as a basic moiety in presence of oxidizing agent and sulfuric acids. The mechanism of this Krebs synthesis is like that. The glycerols undergo first treated with the sulfuric acids and to form the acrolein as an intermediate. This acrolein which undergo react with the conjugate addition with aniline. This acrolein part, they conjugately addition with anilines to form the intermediate enol keto form. This keto enol forms undergo intermolecular additions and to make the cyclized intermediate, followed by aromatization by elimination of protons. Which proton? These protons are eliminated and to make the aromatization of the benzene, followed by protonations, addition of protons towards the hydroxy groups and to make the protonated oxygens, followed by dehydrations, loss of water molecules, and to make the bond, followed by mild oxidations, oxidation in presence of nitrobenzenes. But there is during the nitrations there is a reduction of there is a removal of hydrogen molecules and to make the quinoline, aromatic quinoline was formed. In this way, you have to prepare the Skraup synthesis from aniline react with the glycerin in presence of sulfuric acids, followed by oxidations with mild oxidizing agent nitrobenzenes and to make the aromatic quinolines. This is the mechanism for synthesis of Skraup. Now we have to move with the another synthetic method for the preparation of quinoline, that is Debonnier-Miller synthesis. In this Debonnier-Miller synthesis, again the starting material as in this synthesis is aniline, as we have to discuss in the Skraup synthesis. Skraup synthesis also starting with the aniline, but in Skraup synthesis glycerol are used. Here instead of glycerol, alpha beta unsaturated carbonyl compounds are used. This is alpha beta unsaturated carbonyl compound. This is carbonyl compound. This is alpha positions, and this is beta position. In alpha and beta, there is a presence of unsaturation, double bonds. They undergo treated aniline treated with alpha beta unsaturated carbonyl compound in presence of acids to make the substituted quinoline 2,3,4 substituted quinolines, which they are substituted from alpha beta carbonyl compound substituted groups are substituted at second, third, fourth position on quinolines and to make the aromatic quinoline as a final product. Another method for the synthesis of quinoline is Friedlander synthesis. In this synthesis, the 2-amino-benzaldehyde, here the example, here the structure of 2-amino-benzaldehyde. This 2-amino-benzaldehyde is react with the quinoline. This is a structure of quinoline in presence of acid and to make the substituted quinoline derivatives. That is 2,3 substituted quinoline derivative. Here we have to see with the one example 2-amino benzaldehyde. 2-amino benzaldehyde. They react with the acetophenones in presence of acid to form the phenyl substituted quinol. That is 2-phenyl quinoline is the final product of Friedlander synthesis. The starting material for Friedlander synthesis is 2-amino benzaldehyde. They react with the ketones. In this way, you have to prepare the substituted quinolines. These are the some reaction related with the preparation of quinolines. Now we have to move with the reactions, chemical reactions of quinolines. First, we have to see with the electrophilic addition to nitrogen, pyridine containing nitrogens. They undergo electrophile additions. First is protonations. Quinolines undergo protonation because this is a base. They undergo protonations, addition of protons towards the lone shared electron containing nitrogen and to form the quinazolium salt. This is the first method, that is protonations. Due to the basic nature of the quinolines, they undergo protonation easily and to make the quinazolium salt as a final product of protonations. Second is alkylations, N-alkylations. Which type of alkylation is carried out? N-alkylations. The electrophiles are added into the towards nitrogen atoms. That type of additions is called as N-alkylations. For N-alkylations, quinolines, these unshared electrons undergo react with the alkyl halide and to make the N-methyl quinoline formations. N-methyl or 1-methyl quinoline iodide was formed. This type of reaction is called as N-alkylation of quinolines. This is the first chemical reaction, that is electrophilic addition towards nitrogen atoms. Now we have to move with the second chemical reactions of quinoline, that is ESR, that is electrophilic aromatic substitution. EASR, electrophilic aromatic substitution reaction. Here electrophiles are substituted specifically on benzene ring instead of pyridine rings. Specifically at 5th and 8th position is most favorable positions for substitution of electrophiles on quinoline. Means this side 5th positions and or 8th positions. 5th and 8th giving electrophilic addition, electrophilic aromatic substitution product. For examples, quinolines undergo nitration in presence of nitric mixtures. There is a formation of 5-nitro and 8-nitro quinoline. This is a 5-nitro and this is 8-nitro quinoline with the proportion of 70-30 or 60-40 according to the substitutions. Another reactions of electrophilic substitution is halogenations. Here bromination carried out in presence of aluminum chloride. There is a formation of 5-bromo, this product, and 8-bromo product was formed. 8-bromo quinoline was formed. Similarly, another reaction is the sulfonation reactions. For the sulfonation, sulfuric acid is required in presence of oleums. These sulfonyl groups are substituted at 5th position and 8th positions, and to make the electrophilic substituted product, that is 5-sulfonyl quinoline and 8-sulfonyl quinoline was formed. Now next reaction of quinoline, that is reduction reactions. Reduction means addition of hydrogens or removal of oxygen. But in quinoline, there is no oxygen atoms, so there is an addition of hydrogen in the ring of quinolines. Here, there are different types of reduction reaction possible. There is addition of hydrogen either with this pyridine rings or in benzene rings. Depend on the reaction conditions, the reduction was carried out. Here, the quinolines undergo reduction either with lithium aluminum hydride is used, reducing agents, or in presence of platinums, there is addition of hydrogens towards pyridine containing rings and to make the 1, 2, 3, 4 tetrahydroquinoline. There is no disturbance with benzene rings if lithium aluminum hydride or platinum uh, platinum are used during the reduction reactions. Here another reduction reactions. Here quinolines undergo reductions in place of palladiums with hydrochloric acid. There's addition of hydrogens towards the benzene rings and formation of 5, 6, 7, 8 substituted hydrogen substituted product, that is 5, 6, 7, 8 tetrahydroquinoline as a reduced product of quinoline if they react in presence of hydrochloric acids. Reduction. Hydrochloric acid is used in presence of palladiums. Next chemical reactions of quinoline is oxidations. Here quinolines undergo oxidations with alkaline potassium permanganate. There is a formation of 2,3 dicarboxylic acid containing pyridine as a final product. Further, they undergo decarboxylations and to form the nicotinic acid. One of the carboxylic acids undergo decarboxylations and to form the nicotinic acid or called as pyridine 3 carboxylic acid was formed as a oxidized product of quinoline. And last reactions related with the quinoline is a nucleophilic substitution reactions. Here is substitution of nucleophiles on pyridine rings. The example is GBL reactions. This reactions is carried out with soda-amide at higher temperature. Here example is quinolines is react with the soda-amide in presence of higher temperatures. There is a formation of 2-amino quinoline as a final product. In this way, the nucleophilic substitution reaction was carried out. This reaction is called as Chiche-Babin reactions. This reaction is carried out when reactant react with sodamide at higher temperature. That reaction is called as Chiche-Babin reactions. There is substitution of nucleophile at second position. These nucleophiles are substituted on pyridine ring of quinoline, that is 2-amino quinolines. And now move with the last part of the heterocyclic compound, that is quinoline's medicinal uses. Some examples of quinoline containing drugs, that is quinine. Most of the drugs are antimalarial drugs having quinolines, that is quinine, quinolines, chloroquine, most important antimalarial drugs, amidoquines, primaquines, bulaquines. These are the drugs having quinoline as a basic moiety. For example, this is structure of quinolines, chloroquines. This chloroquine contains quinoline is a basic heterocyclic moiety. At 7th position, chloro is present, and 4th positions, amino group is present. That's why In the antimalarial classification, they are classified as a 4-amino quinoline drugs. These drugs are treated for parasite malaria against malarial infections, either from Plasmodium malaria, Plasmodium species, if infected to the human beings. On that conditions, these drugs are used, effectively used against malarial infections. Another drugs having the quinoline, that is quinoline antibiotics. There is structure of quinolines containing antibacterial agents, that is ciprofloxacin, ofloxacin, norfloxacin, lomifloxacin, sparfloxacin, having this basic skeleton of quinolines. These quinoline antibiotic act as a antibacterial agents. So these are the medicinal drugs having quinoline as a heterocyclic moiety present in the structures, and they produce the respective biological activity or respective activity depend on the nature of the compounds or depend on the nature of the drugs. They are used for the particular treatments. For the preparation, these are the references we have to use for the making of these presentations.